Namaste everyone. Hope you are doing well. In the last class we have seen about refraction. When a light moves from one medium to another, it changes the direction, it changes the speed, so it chooses the different path. That is called refraction. So change in the direction of ray of light when it travels from one medium to another medium. That is called refraction. So we have seen so many things in refraction. Suppose this is medium 1 and medium 2, maybe any media, maybe water and glass, oil and water, anything, any combination. So we define angle of incidence as the angle between incident ray and normal, and the ray, instead of traveling in the same straight direction, it bends towards the normal if its velocity is decreasing in this medium. So if the velocity is less here, then it will bend towards the normal. So this is the angle of refraction, angle between refracted ray and normal. And here we define the two laws. We state the two laws, not defining. We state the two laws of refraction. First law is the incident ray, the refracted ray and the normal line all lie in the same plane. So incident ray, refracted ray and the normal line all lie in the same plane, and the normal line should be drawn at the point of incidence to the surface. Okay, what about the second law? Second law says the ratio of the sine of angle of incidence to the sine of angle of refraction is always a constant, but you are not allowed to change the pair of media and test this. You are not allowed to change the color of light and test this. This has to be tested. Whether you get the same constant or not has to be rectified, or it has to be checked by taking the same two media, same color of light. Then what is that we can change, sir? It is the angle of incidence. Automatically it changes the angle of refraction such that sin I by sin r is a constant. So you are allowed to change I and r. That you can do. For any I and any r, this holds good, except for normal incidence. When the ray of light is taken here, I is 0, r is 0, sin 0 by sin 0, 0 by 0 is not defined. So Snell's law fails at this normal incidence, which is normal to the surface, but angle is measured with respect to the normal, so I is 0. Okay, so if you want to use this constant to identify some media, like sir, for which pair of media you get this constant? So for example 1.33, 1.5 or 2.22, like this, and that value will indicate that you have taken this pair of media. That's why this is called refractive index, and we use this constant as a index number to represent it, to index or to represent the pair of media. So what is refractive index? And we represent it like this. It is the refractive index of the second medium, because refraction is occurring in the second medium, but with respect to the first medium. This is just a recall. We will have a small recall of all the things we have studied, and then we will proceed. So define refractive index of a medium. Refractive index of a medium with respect to another medium is the ratio of sine of the angle of incidence to the sine of angle of refraction. Or you can define it like this. When a ray of light travels from one medium to another, the ratio of sine of the angle of incidence to the sine of angle of refraction is always a constant, and that constant is called refractive index of the second medium with respect to first medium. Where the light undergoes refraction, that has to be written first, and the other medium next, because refraction is occurring here. So this is one particular case. Now suppose if a ray of light, and say this is rarer medium, if it has to bend towards the normal, it should travel from rarer to denser medium. And if a ray of light is traveling from denser to rarer medium, say this is water, a ray of light is incident inside water, it, instead of traveling in the same straight line, it will bend away because its speed increases. Now this is the angle of incidence, and this is the angle of refraction. Here r is more, I is less, whereas here I is more, r is less. So here r is more and I is less. And here it bends away from the normal, and medium 1 is here, medium 2 is here. Now refractive index of medium 2 with respect to medium 1, of course if I can use the same r and I here also, then this becomes IR, this becomes I. Only in terms of notation, because suppose you have a media such that, suppose 30 degree is the angle of incidence, say 20 degree is the angle of refraction. If you take a laser beam and put it in the same laser beam and put it in 20-degree angle inside, it will move by 30 degrees. So which is I now? 20 degree. Which is R? 30 degree in this case. So if you use now N21, okay, now 21 also has to be changed. This is 2 and this is 1, and now the ray is traveling from denser to rarer medium. It is doing quite opposite thing what it did here. So N21, so this is now refractive index of the second medium with respect to the first medium is the ratio of sine of the angle of incidence to the sine of angle of refraction, which is nothing but 1 by sine I by sine R. You know this, we did this all these things in the previous classes. N12 is equal to 1 by sine I by sine R, N by 1, so yes, N21, yes, because sine I by sine R is N21, this is N21. Now, so what are the methods of calculating refractive index of any media? There is one more simple method, you know that what is the speed of light in the first medium, V1, what is the speed of light in the second medium, V2, then refractive index of second medium with respect to first medium is nothing but sine I by sine R. It can also be defined as the ratio of speed of light in the first medium to the speed of light in the second medium. Even though we are defining the refractive index of the second medium where refraction has occurred, see, the numerator contains all the first media characteristics. Velocity of light in the first medium, sine of the angle of incidence. Okay, what about here? Here, the ratio of velocity of light in the, velocity of light in the second medium is V2, V1. Say this is glass, inside glass velocity is V2, here it is R, say. Then, this one can also be written as N12 can be written as refractive index of the refracting medium to the incident medium ratio is equal to the ratio of velocity of light in the first medium to the velocity of light in the second medium, V2 by V1, which is also equal to 1 by V1 by V2. You can bring V2 to the denominator. What is V1 by V2? V1 by V2 is nothing but N21. So 1 by N21. You can write it like this. So now another common thing of refractive index is in usual notations we say the refractive index with respect to R, because always the first medium, changing the first medium, second medium, it's a very long process. We will have one medium common, that is first medium. So refractive index with respect to R. Okay, so with respect to R, if you want to define, what do you mean by refractive index with respect to R? Take the first medium R. Any medium, say glass. Second medium is glass. So this is first medium, second medium is glass. A ray of light is incident, it bends towards the normal, because in air velocity of light is highest and definitely it is lesser in glass. So I, R. Now refractive index of glass with respect to air, that is refractive index of second medium with respect to first medium, is the ratio of velocity of light in the first medium, C, which is nothing but V1. This is instead of V1 written. Velocity of light in the first medium is nothing but the velocity of light in air divided by velocity of light in the medium, and that is glass. This is in air. Of course, this need not be written. C or VA by VG. VA is C. So this is what we write. So if you take any medium, this is medium. In general, I write medium. Sir, which medium? Any medium that you have in your hands. Maybe glass, maybe water, maybe plastic, whatever it is. This is air. And so refractive index of any medium. Sir, don't you want to write anything here? No, it is this medium only. Sir, what about the first medium? Air, understood. So refractive index of any medium is equal to velocity of light in air to the velocity of light in the medium. Sir, don't you want to put a suffix here? No, because the second medium should be the medium what you are considering. First medium should be air. So this is in general we write it. Refractive index has no unit, and because it is velocity by velocity, and so it is unitless quantity. Now what does refractive index signify? It signifies the speed of light in that medium. One significance. That is, it will give you an idea about how the light travels, how does the light travel in that medium. More the refractive index, n equal to c by v. More the refractive index, lesser will be the speed of light in that medium. Refractive index of diamond is 2.22, say. Speed of light in that medium is least. Refractive index of glass is less, 1.5. Speed of light in that medium compared to diamond is most. So more the refractive index. Suppose refractive index of diamond is greater than refractive index of water, say. What does it mean? Velocity of light in diamond is lesser than velocity of light in water. That is the meaning, because they are inversely proportional. This is constant everywhere. So we need refractive index to study the light which is traveling in any medium. Okay, so now whenever you write this, you can write one more thing regarding to this. So I will connect this to the next topic. Okay, so shall I write it here? Right? Yes. Now, what is that I have to connect? Sir, when you have two media, say separate, 1 and 2. Of course, this is not needed for the, as it is not needed for exam, but this idea is needed throughout your discussion in the optics. One ray of light incident comes like this. This is I, this is R, angle of refraction, angle between the refracted ray and normal. And let the speed of light in this medium be V1, speed of light here be V2. Now, what is N, refractive index of the medium where ray undergoes refraction, second medium. With respect to the first medium is velocity of light in the first medium, velocity of light in the second medium, that ratio. Ratio of velocity of light in the first medium to the second medium. Right. Okay, this is normal case. Now, take the first medium. So both, out of both, neither one is air. Now, one is not air, 2 is also not air. Take the two media, right? Take the two media and right? Take the two media, keep them separately with respect to air. Take first one, keep the first medium as the second one and compare it with respect to air. Do the experiment. Let's take a ray of light, pass it through that first medium. After being incident in the air, let it enter into the first medium. Okay. Now, C is the velocity of light in air. What is the velocity of light in the first medium? Already we have defined, it is V1. It does not depend on the second medium, right? Velocity of light in a medium does not depend on what the velocity or what it is surrounded by. It depends only on this medium. So V1, even though it is surrounded by air here, velocity is V1 only. Even though it is followed by another medium, here is V1. So C by V1, okay. So what is the refractive index of this medium 1 with respect to air? Refractive index of the medium where light is undergoing refraction with respect to air, N1 is equal to C by V1. Correct? Velocity of light in air to the velocity of light in the medium. Okay, now medium 2 is waiting there. It also requests you, sir, give me a company with the, or give me a chance to make company with the air. Okay, take the second medium and make it friendship with the air. Let a ray of light travel from air to the medium, second medium. Let the velocity of light in air be C. Velocity of light in the second medium is V2. So how do you define refractive index of second medium with respect to air? Refractive index of the second medium with respect to air. Air I need not write, it is common. Velocity of light in air, velocity of light in the first medium to the velocity of light in the second medium. Equation 2, equation 1, now compare them. And here you have equation 3 say, or 0, whatever it is, no problem. Compare them. I'll take this equation. N21, V1 by V2. Just for understanding this one. This derivation or this process of connecting the refractive indices is not for the exam. V1 by V2. Okay, that we know. Multiply and divide by C. By C, by C. Okay. Into C by C. Now, I will retain C by V2 like this. Okay, you know this? Refractive index of second medium with respect to first medium means when 1 and 2 are together. When they were together. Now 1 is separated and it is made to make a friendship with air. 2 is separated, it is given a chance with the air. So this is refractive index of 1 with respect to air, 2 with respect to air. You all know this. Now let us try to put these two things here. How, sir? Very easy. Multiply and divide by C. C by V2 you keep it as it is. V1 you bring it to the denominator. C by V1. So N21 is equal to C by V2 into 1 by C by V2 1 by C by V1. Am I right? Because this V1 was in the numerator. In the numerator we had C and V1. This V1 comes to the numerator, C and V1, V2 and C, V2 and C. This is okay, right? So what is N21 is equal to? N21 is equal to C by V2, N2 divided by C by V1, N1. This is very important. Not as a derivation, as a knowledge, because we are going to use this formula everywhere. So what does this mean actually? If you have a pair of media, two media, and if the light travels from one medium to another, you can compare that process with when the two media are separately kept with respect to air, and what is the refractive index. So refractive index of second medium with respect to first medium is equal to refractive index of the second medium with respect to air, first medium with respect to air. That's all. It's the ratio. So refractive index of second medium with respect to first medium is always equal to refractive index of second medium, the ratio of refractive index of second medium with respect to air and refractive index of first medium with respect to air. So here onwards, if you are given any refractive index, remember it is not the refractive index of any medium with respect to other medium. It is the refractive index of some medium with respect to air. Suppose if I say refractive index of air is refractive index of glass is 1.5. What do you mean by that? It is the refractive index of glass with respect to air, not with respect to something else. If it is with respect to something else, you must mention, sir, second medium is glass, first medium is water. You have to mention it. Unless mentioned, it is air. First medium is air. Okay, now if you write Snell's law, right, I'll take one example, medium 2, medium 1. Let the light travel from medium 1 to medium 2. Velocity of light in the first medium is V1. Velocity of light in the second medium is V2. Now, angle of incidence is I. Angle of refraction is R. Okay? Now, how do you define refractive index of second medium with respect to first medium? It is nothing but sin I by sin R. It's nothing but V1 by V2. And you know, when the light travels from one medium to another, its wavelength changes. Lambda 1 by lambda 2, because V equal to nu lambda, or C is equal to nu lambda. Nu gets cancelled. This one I have forgotten to say. When a light travels from one medium to another, I will tell it now only because I will forget it. What are the characteristics that the light having will change? What characteristics of the light will change when it travels from one medium to another? Does its speed change? Yes, speed changes. Does its wavelength change? Yes. What about frequency? Doesn't change. So whenever, maybe light or any wave for that matter, when it travels from one medium to another medium, its velocity changes, its wavelength changes, but its frequency remains the same. So how did you get, sir, this formula? What is V1? Nu lambda 1. What is V2? Nu lambda 2. Because nu is same here and here. So frequency of wave doesn't change when it moves from one medium to another. The number of cycles of repetition per second, that doesn't change. But wavelength changes, velocity changes. Since nu is a constant, when a wave travels from one medium to another, if velocity decreases, lambda also decreases. If velocity increases, lambda also decreases. Directly proportional lambda, nu is a constant. So nu lambda 1, nu lambda 2, nu gets cancelled. So it is the ratio of wavelength of light in the first medium to the wavelength of light in the second medium, but is equal to N2 by N1. So this formula should be always with you. So you make a list of formulas, right? We have got many formulas. Take a small sheet of paper and write all the formulas. We have got N equal to C by V and sin I by sin R, Snell's law and everything. Write all those formulas, keep it in a sheet of paper. Whenever you are free, just look into that formulas, because that is the best way of remembering the formulas. Otherwise you will forget. You will have plenty of formulas to remember. Okay, always keep that sheet of paper with you, formula list, but don't take that formula list paper to the examination hall. That is a very dangerous thing. But everywhere you can take it, except exam hall. Okay. So this is, see, any formula you can see, no unit. Lambda wavelength, meter, no unit, cancels. And V1, V2, meter per second, cancelled. Sin I, sin R, mathematical functions, no unit. And here, refractive index, no unit. So, here it is N2 by N1, N21. Now, take this formula and take this formula. This is easy to remember finally. So, I want this final result. Cross multiply them. So, sin I by sin R must be equal to N2 by N1. What is N2 and N1? Refractive index of second medium separately with respect to R. We did it here it is. Refractive index of second medium with separately with respect to R. Sir, what is N1? N2 is refractive index of second medium separately with respect to R. What is N1? N1 is the refractive index of the first medium separately with R. When this was with R, what is its refractive index? So, these are the refractive indices with respect to R, and if you divide it, you will get refractive index of the second medium with respect to first medium. So this is relative, this is with respect to R. Now, see here, in order to remember the formula, I, first medium, velocity of light in the first medium, wavelength in the first medium, but this one is reverse. Refractive index of that second medium with respect to R divided by refractive index of the first medium with respect to R. Okay, so cross multiply this one now. Sin I by sin R must be equal to N2 by N1. What you will get? N1 sin I, now the equation finally lands in a very simple manner, very simple. N1 sin I is equal to N2 sin R, no confusion at all, and this is another form of Snell's law. We call this also as Snell's law. Finally this, because we have got it from the Snell's law itself, sin I by sin R equal to N2 by N1. Similarly, so same idea, N1 sin I is equal to N2 sin R. This is called general law of Snell's law. Now how to remember this? Very simple. Which medium? For example, this one, its refractive index is N1. With respect to R, the refractive index of this is N2. With respect to R, what about the relative N21? That you know. N21 is equal to N2 by N1. That we know. Now, N1 sin I is equal to N2 sin R. Finished. Nothing to study here. Wherever you have the angle of incidence, take the sine of the angle of incidence, multiply it to the refractive index of the corresponding medium only. You need not confuse and go to the other medium. Same medium refractive index, sine of the angle of incidence or refraction, that. So N1 sin I, N2 sin R, refractive index here, sine of the angle here. So their product must be same everywhere. So N1 sin I is equal to N2 sin R. This is very important formula. Everywhere we are going to use it for derivations, for working out problems, and many things. Okay, so that is one area. Of course, all these steps, better you know this, need not be in a methodic way, because there is no chance of getting it in a theory exam, but this is very important. That is needed. Okay, now, we will use this now. We will draw a diagram. So have a pen and paper, you have to write this. Suppose you are asked to draw the diagram, not a very important question, but very easy answer for this one. Draw the ray diagram of a ray of light undergoing refraction in a parallel sided slab, glass slab. For example, if I have a glass slab like this, then show the angle of refraction and everything, and here in the parallel sided slab. So this is a glass slab having parallel sides like this. Like this. Right. Now if you incident a ray of light, how will it undergo refraction? That is the question. And how do you show this? So you can take a pen and paper, or you can start drawing it along with me, and you have to note down all the formulas. All that steps are not very much needed, just understand it. Okay. Take a ray of light. Let me introduce a ray of light like this on the glass slab. Let us assume that these two sides are parallel. Okay? Now, what you have to do now here, if you want to show how does it undergo refraction, say this is air and this is a glass slab. And now, if this is the situation, ray is traveling from air to glass, velocity decreases, it should bend towards the normal. First of all, you identify the original direction. This is the original direction. And I am going to explain you now lateral shift. What do you mean by lateral shift? We will see. Okay, we will see what is lateral shift. Let a ray of light undergo refraction through a parallel sided medium. Take a ray of light incident on a glass slab. These two sides, let they be parallel. Name them PQRS. Or ABCD, sorry. PQRS, let us take ray as a PQRS. ABCD is a rectangular glass slab. ABCD. Okay. Original direction is not a straight line. It should be a straight line. Okay. It should be like this. Right. Now, draw a normal. If you want to see how the ray of light undergoes refraction, you should draw a normal. No, I have to use a different color. Don't know whether you can see the colors or not. Yes, this is the normal drawn to the surface, because you see, why do we draw the normal? Normal is drawn in order to define the angle of incidence and refraction. Where you have to draw the normal? To the surface where the light is falling. Where you have to draw it? At the point of incidence. Okay, normal. And now it should bend towards the normal. So the ray of light moves like this. This is the refracted ray. So it bends towards the normal and moves. And everywhere I am indicating arrow marks. Remember, if you forget to write all these arrows, you will lose many marks. In physics, already I have told you are losing marks in quantas. Either 1 or 2, no 1.5 half fraction at all. Okay, now where is the angle of incidence? Angle between incident ray and normal. I1 I will call. What is the angle of refraction? Angle between the refracted ray and normal. R1. Normal and refracted ray. In the beginning itself I have told, if you want to mention angle of incidence, refraction, etc., go along with the definition. Don't leave definition at all anywhere. So angle between incident ray, normal. Refracted ray and normal. Angle of refraction. Okay. Now what happens here to the ray of light? When the ray of light falls here, again a normal. Okay, yellow color normal. Okay. Now the ray of light is traveling from denser to rarer medium. This was its direction. I don't show it exactly. Just for my knowledge, I will show it like this. This was the direction here. Now it should bend away from the normal. Why? Because its velocity is increasing. Denser to rarer. Optically denser medium to optically rarer medium. It should bend away from the normal like this. So this is not needed. Just to know that it is bending away from the normal. I have drawn it. Okay. So finally the ray emerges out like this. Remember, if these two sides are parallel, exactly parallel, these two sides, the sides where the refraction is occurring, I am not bothered about this surface, whether this surface is like this or this one is surface, I don't bother at all, because ray of light is not undergoing refraction there at all. So only those two faces where the ray of light is undergoing refraction, if they are exactly parallel to each other, I can assure you that these two rays are also parallel. Definitely they will be parallel. And if I can show it like this, if this is the next angle of incidence to the second surface, I2, and this is the next angle of refraction, of course you can interchange it, no problem. Because, sir, can I write I2 here and R2 here? No problem, because, sir, how do you call this as I2? The ray is undergoing refraction. Write as a reversible property, principle of reversibility. If you take a laser beam and put it like, the ray of light has changed color, okay, it changes color, let it be. But here and here it should have the same wavelength. Okay, take a laser beam, put the laser beam like this. It undergoes refraction and moves like this. Okay. Now if I take a small mirror and keep it here, what will happen to that laser beam? It gets reflected normally like this and it will follow the same path. So no problem. Or take a new laser beam and put it like this, it will follow the same path. So if you can put the ray like this and it undergoes refraction here, and if you name it as R2, if you take the same ray like this, it becomes angle of incidence and the ray follows the same path. So naming is okay, no problem, because just mentioning the angle is very important. You have to mention the correct angle, whether it is R2 or I2, whatever, doesn't matter. So I1 R1, I2 R2. Okay. So now if this glass slab is removed, what will happen to this ray? It will never bend, because everywhere it is air. It would have moved straight. if that glass slab is placed, what is the final result? The ray of light is now finally traveling like this. Because of the presence of glass slab, what is the change observed? Only this much. Light which was traveling like this, because of the presence of glass slab, it has been shifted here. How it has been shifted? Laterally shifted, sidewise. You were going like this, right? You are traveling like this. Suddenly you happen to see your teacher. You will move like this. You have been deviated and you have been shifted. Now it is shifted parallelly, and this perpendicular distance is called lateral shift. Suppose you are asked, of course, that definition, what is lateral shift? It is the perpendicular distance between what? Because even though the word is only lateral shift is the distance. We are mentioning the distance there. Which distance? Lateral shift is the perpendicular distance between the incident direction and the final emergent ray. When a ray of light travels through a parallel sided medium. So when a ray of light passes through a parallel sided medium, maybe glass or the upper and lower layers of water in an aquarium, whatever it is, when a ray of light passes through a parallel sided medium, the perpendicular distance between the incident direction and the final direction, both the directions are same, it is just displaced, that's all. That perpendicular distance is called lateral shift. So perpendicular distance between the incident direction and the final direction when a ray of light is passing through the parallel sided medium is called lateral shift. All those definitions you will get in the book or notes wherever it is, but try to understand the concept. I am focusing only on mainly on the concepts. In between I will tell you how to write the answers in the exam. So here you will draw the diagram to represent lateral shift in a glass slab, one, and may get a definition but not very important one. What is lateral shift? And you can answer it like this also. The shift in the direction of ray of light when it passes through a parallel sided medium is called lateral shift, or perpendicular distance between the incident direction and the final direction when a ray of light passes through a parallel sided medium. That is called lateral shift. Now, simply if they ask a question, what is the reason for lateral shift? Just refraction. Suppose there was no refraction, light would have moved straight and there would have you may not have observed any lateral shift. It is because of refraction. So write one consequence of refraction, whatever you observe from refraction, lateral shift. Second observation of refraction is normal shift. Sir, what do you mean by normal shift? That we will see. Normal shift. This is another consequence that we observe from refraction of a light. When it travels from one medium to another, it changes its direction. Normal shift is very simple. We see that in our day-to-day life. That is, so put a small coin inside a beaker, pour water into that. When there is no water, the coin appears in the same place where it is. When you pour water, the coin appears to be shifted upwards. The bottom of the swimming pool appears to be shifted upwards. A pencil kept in a beaker containing water appears to be broken. These are all because of normal shift. So shift in the position, it is apparent, it is not real. Suppose you are crossing a small stream in a village. Imagine small amount of water is flowing in a stream. You can see all the stones and things inside water. You feel that it is very shallow, it is not deep, but if you put your leg, you will come to know that it is very deep. Your imagination of depth will not be true when you really put your legs into that, and depth will be more. And why it is so? That is because of refraction, and that is called normal shift, and it is not real, it is apparent. If you put your hands into the beaker containing water in order to take the coin out, you will find that coin is deep inside. It is not as if it is found. That is apparent shift. So you have to start it from apparent shift. So if this is a beaker containing water and if the coin is really here and it appears to be here, this is the position where it appears to be and this is really where it is. There is a shift, and let us observe this from here. Remember that apparent shift can be observed anywhere. Suppose you look into the swimming pool. Usually swimming pool bottom will be painted with some color, or there will be mosaics of different color. So you see that colored bottom shifted upwards. And if you observe it obliquely like this, there is a shift. If you observe it normally, there is a shift. But we measure it only when it is observed normally, because we should have a convenient or common scale when we define. So let us observe the coin normally. There is a shift in the position, apparent shift. So these two words, so add these words to your dictionary, apparent shift. Apparent change in the frequency of sound. Do you remember? Long back when you were in first PUC, might have forgotten it. So you have studied that apparent change in the frequency of sound when there is a relative motion between the sound and the observer, source of sound and the observer. Long back when you were sleeping, you might have heard your teacher crying like this. So that is the apparent. That is not real. We feel it so. Frequency appears to be changing. Similarly, apparent shift. What? In the position of object. Okay, object position appears to be shifted for us. When the object is kept in one medium and viewed normally from another medium. That is called normal shift. So what is normal shift? Normal shift is the apparent shift. It is not real, whatever we feel. Apparent shift in the object position, kept in one medium, viewed normally from another medium. So if you look into the bottom of the swimming pool, it appears to be shifted upwards when you are in air and when the bottom is inside water. Jump into the swimming pool, try to look into the bottom. It appears to be in the same place where it is, because you are observing it from the same medium. So if you observe the coin from the same medium, there is no shift. So all these things should be mentioned in the definition. Apparent shift in the object position, which is kept in one medium and viewed normally from the other medium. So every word is important. If you miss any one keyword, you lose the mark, and it doesn't carry meaning. Okay, apparent shift in the position of object, kept in one medium and viewed normally from another medium. That shift is called normal shift. Okay, sir, can we measure this normal shift? Sir, and remember, air is the medium which has got least refractive index, 1. Refractive index of air is 1, because refractive index of any medium is the velocity of light in air to the velocity of light in medium. So refractive index of air is velocity of light in air divided by velocity of light in air itself, 1. Yesterday, in the previous class we have discussed it. R is the medium which has least refractive index and light travels with most speed. Okay, if you are observing a coin inside a beaker, you are in air. If you are observing at the bottom of the swimming pool, you are in air. So if you observe from the rarer medium into the object kept in the denser medium, it appears to be shifted nearer to you. It always appears to be shifted closer to you. Bottom of the swimming pool appears to be nearer to you than what it is actually. Coin appears to be nearer to you than what it is actually. Okay? Now, so things kept in the denser medium appear to be nearer to you when observed from the rarer medium. If you do the other case, go inside water. You swim inside water, and when you are swimming inside water, you are swimming, this is your nose. It looks to be very strange, but still you must understand it. So if you are looking upwards, swimming inside water, how do all the objects outside appear to be? Everything appears to be far away, and far away. So for a person inside the denser medium, things kept in the rarer medium appear to be very far away. So there is a normal shift which is more. So birds, suppose there is a bird which is actually at a height of 50 meters. For the person inside water, this appears to be more than 50 meters. So every coconut tree, everything appears to be longer and longer and longer. So if the object is in the rarer medium, observer is in the denser medium, everything appears to be longer. And if the observer is in the rarer medium, usual case, when the things are in the denser medium, they appear to be nearer. So for a fish, this world will be larger than what it is for us. Whatever the world that you see sitting in air itself, everything appears to be in the normal positions, because there is no difference. Because objects are in air, you are also observing from air. For a fish, this world will be longer and longer and larger. Every coconut tree will appear to be longer because it is in the denser medium and we are objects in the rarer medium. So that is the case. So now, sir, is there any formula for finding this shift? Suppose there is, there should be a ray diagram. We will draw a ray diagram and we will write a formula for refractive index. then we will stop at a stage. Okay, sir, this is the line which separates the two media. This is the bottom, and here is an object, say a bulb. Now you can consider any amount of rays of light. Say this is normal. Do you know any ray of light incident along the normal, angle of incidence is 0 and angle of refraction is also 0. Snell's law cannot be applied here, but still it moves like this. Take a ray of light. This is a bulb now. I want to observe the bulb from here, from this side, and I want to see where the bulb appears to be. Now, take another ray of light, incident at some angle. It is moving from denser to rarer medium. Imagine that this is water, and instead of traveling in the same direction, it will bend away from the normal, like this. Am I right? You have to keep on drawing. I don't say that you have to draw it again and again. You have to draw this. Whenever the ray diagrams come, you have to draw this. Scribble it in a rough paper. Take some buff papers and keep on writing it. That is the best thing you can do. And all these ray diagrams, derivations and everything, usual persons will forget it. But if you want to avoid forgetting, write it when the teacher is doing. Scribble something. It will remain somewhere in your brain. And go home, teach it to your parents. Whether your parents understand it or not, that is secondary. You will understand it better. So teach whatever you have studied to your friends, to your neighbors, to your uncle, auntie, and finally your parents. And if nobody is available, what the cat that you have in your house or a dog, you just ask cat or dog to sit by your side, teach him. The cat and dog will never understand anything, but you will understand it better. That is the best way of learning. Teaching is the best way of learning. We remember all these things because we teach so many students again and again. So we remember this. Okay, so this is the angle of incidence. Remember? Angle between incident ray and normal. What about this refracted ray? Bending away from the normal, denser to rarer, speed increasing. Angle of refraction. Take another ray of light which is moving at the same angle here. Oh, right. It is like this. Take another ray of light moving at the same angle. So I will draw a normal here. So keep on drawing this along with me. So this is another ray of light moving from denser to rarer medium. Now it also bends away from the normal. This is the normal, and it should bend similar to this one. Okay, so it bends away from the normal. This is the angle of refraction for this ray. Of course, this diagram is totally exaggerated. Actually, these two rays must be very, very close, because for an observer here, he will have two eyes. These two rays must enter his eyes. You know at what width your eyes are. So when you look at the coin, many rays will be coming from the coin inside beaker. And some of the rays which are coming here, you can't see them at all. They simply escape away. You will see the rays of light which are only within this range. Only those within this range will enter your eyes. So they must be closer. But our diagram is a little bit exaggerated because it should be legible, and if you draw this within only the range of your eyes, the diagram will be rays of light will be very close, and you will not be able to identify all the angles. So that's why we have exaggerated it. But see the situation, when you are looking into a coin kept inside water, you will receive only those rays of light which are almost with the normal and with the small angle of refraction. So these two rays which are entering the eyes, if they are very close, which are entering the eyes, how do these rays appear to be for this observer? This observer feels that these rays are not coming from this point, these rays are coming straight like this from this point. So he feels that these rays are diverging from this point. So this should be the coin according to the observer. So this is object. From this object, the rays of light have come like this, one arrow after refraction went like this. Another ray of light, one arrow after refraction like this. Okay, it is like this. And this is normal incidence, and you know, no refraction angle, no incident angle, 0. That is a normal incidence. But for a person observing from outside, these rays appear to be coming from this point. I, that is the image. So this object appears to be here. Now let us indicate, please draw this, don't keep idly, and you should know what is happening here. Now we define some of the heights here. What are the heights? Shift in the object position, kept in one medium, viewed normally from another medium. This shift, normal shift. So normal shift is the shift in the object position, kept in one medium, viewed normally from another medium here. So this shift is normal shift. Sir, can we draw any, or can we indicate this depth by anything? This is the depth at which we see the object, but it is not real. So apparent depth. Please keep on writing this. So apparent depth is the depth at which we can see. Of course, no definition is required here. At which depth it is seen, apparent depth. At what depth it is really situated, real depth. So real depth is from the actual surface to the actual position. Apparent depth is from the surface to the seen position, where it is, where it appears to be. And normal shift is the shift in the object position. This is normal shift. Sir, if n is the refractive index of this medium, sir, what do you mean by n? It is the refractive index of this medium with respect to air. Say glass, what is the refractive index of glass with respect to air? If it is water, what is the refractive index of water with respect to air? Then n is equal to real depth divided by apparent depth. I don't write the full sentence. Refractive index of any medium is real depth by apparent depth. What is real depth? It is the actual depth at which the object is. What is apparent depth? It is the depth at which the object is seen. So real depth by apparent depth gives the refractive index. So this formula is important, this diagram is important, and of course lateral shift diagram is also important. But this, out of all, this formula is very, very important. Real depth by apparent depth. And we will continue this in the next session, how to use this formula and what are the different types of questions or even entrance exam. How to analyze this formula using for entrance exam questions. That is very important. Looks to be a very simple formula, but it's very important. We will see that in the next session. For the timing, we will stop it here. So be ready with diagram. This may be asked. Draw a ray diagram for showing the normal shift, and write a formula which connects refractive index, real depth, and apparent depth. So you can write it like this. And okay, one thing is, always when you write the answers in the examinations, you give last chance to ray diagrams. Suppose you don't know answer. Suppose if it is asked for 3 marks or 2 marks, in a 2-mark question, many questions you don't know the answer, then choose this. Otherwise, if you know the answer for other questions, better choose them, because most of us are very good in drawing. So there may be chances of forgetting these arrows. So you will draw everything, say you have forgotten these 2 arrows, say. Suppose it's a 3-mark question, 2 marks have gone. Sir, these 2 arrows carry 1 mark. Yes, every arrow is very important. So such things may happen under pressure. So choose other questions, but I am not saying that don't study this one. You don't carry it to an extremity, right? You have to study this, but you have to choose this question as an answer only when you don't know other things, okay? This is just a small suggestion. But if you are good at drawing, okay, you study this one. Sir, I don't know the explanations and all. I understand only diagrams. Okay, study the diagrams and write it. So that may be a question, but this formula is very, very important. We will analyze the formula in the next session. Okay, thank you. Do well.